All right, greetings everyone. Welcome to the second part of the video for section 2.2. And now that we've had the opportunity to look at some different ways to graph linear functions, we're going to look at kind of some more analysis side of looking at graphs of lines or really linear functions. Okay, so let's talk about what are called horizontal intercepts. And a couple of questions that will first come up. So the first one is, what do we mean by horizontal intercepts? Okay. And the next question would be, how do we find them? All right. So if you imagine if we have a graph of a function, and let's say it's a linear function, so something like this. Okay, so we'll call that linear function f of x. The horizontal intercepts, if I'm referring to that, I'm talking about the point or points where this function intersects the horizontal axis. So I'm talking about, in this case, this point right here. I want to just highlight it in green. Now, some of you from your mathematical pasts may know that as the x-intercept we're talking about. But as I've already reiterated many times, we are not always talking about x's and y's as our variables, right? We could have a function, instead of calling it f of t, it could, for example, be a function called v of t. Sorry, did I say f of t? I meant f of x. So we could call it v of t, which in this case now t would be our horizontal variable and v would be our vertical variable, or t would be our input and v would be our output. So this thing right here would not be an x-intercept, but it would actually be a t-intercept. Okay, so this is why I'm trying to get us to move away from that vocabulary, x-intercept or y-intercept. Okay, here we're talking about horizontal intercept, so it will be where it intersects the horizontal axis, which is the one that generally has the inputs on it. Okay. All right, but in this case, again, we're calling our function f of x. And the horizontal intercepts will be where it intersects the horizontal axis. And note that for any point along that horizontal axis, and in this case, because we're using x as our input variable, the coordinates there will be x, comma, 0, right? So for that point I've identified there, if I was talking about this one right here, it would also be of the form x, comma, 0, right? It could be 1, 0, 2, 0, 3, 0, whatever it is, the coordinates would be x, comma, 0. And so what we see is that for every point along that horizontal axis, the output value here is 0. And that's what can help us find our horizontal intercepts, is we know that at a horizontal intercept, the output value is always 0. Okay? So if we look at the functions at the bottom then, like for example, f of x equals 3x minus 1. If I want to find the coordinates of the horizontal intercepts there, well, as I just mentioned, okay, the output values, so what would be here, would have to be 0. So we can set up an equation here, whoops, but not like that, that is as 0 equals 3x minus 1. We can solve that by adding 1 to both sides. Cancel here, we'll end up with 3x equals 1. Divide by 3 on both sides. So we'll end up with x equals 1/3 as the input value at our horizontal intercept, which tells us our horizontal intercept for this function would be 1/3, comma, 0. Again, because it has that form of x, comma, 0. Okay, so output of 0, and the input in this case is 1/3. All right, let's do a similar thing for the second function here, so this one. So again, when we find the coordinates of the horizontal intercept, we'll set it equal to 0. So if 0 equals 1/4 x minus 11, solve for x. So we'll add 11 to both sides here. Okay, so I have 1/4 x equals 11. To solve for x there, we need to divide on each side by 1/4. Okay. And so we have x equals, and we do 11 divided by 1/4. Okay, we're dividing with fractions there. And notice we can make the 11 on the top an 11 over 1. So to divide these two, recall that what we do is we keep the first fraction, so we keep it as 11 over 1. We change the division to multiplication, and then we flip the second fraction. So instead of 1/4, we get 4 over 1. So the problem becomes 11 over 1 times 4 over 1. If we multiply straight across, we'll get 44 over 1, which is just 44. So the x value here is 44. So then we know the coordinates of our horizontal intercept there will be 44, 0. Okay? All right, last one now. We have this function j of x equals 3. It's a constant function, and as we talked about before, constant functions are linear. And so we can set this one up the same way as before, right? We set the output equal to 0. So the equation becomes 0 equals 3. Hold on, wait a second. Wait just a second. Is that true? Does 0 equal 3? I don't think so, right? 0 does not equal 3. That's what that line through there is supposed to say. 0 does not equal 3. So what does that mean about our horizontal intercept here? Right, it actually does not exist. Okay, there is not one. And can we think about why that is? Well, if you draw a picture here, again, we said j of x equals 3. That's of our form like f of x equals c. That's one of our toolkits. So that would be a constant function. And we know the graph of a constant function is a horizontal line that passes through this value, right? So the graph of this is going to look something like this, where it passes through 3 on the vertical axis. And notice that that line, no matter how much we extend it in one direction or the other, right, whether we go this way or this way, okay, it's never going to intersect the horizontal axis. So that's why in this case there are no horizontal intercepts. All right? Word. Okay, let's next talk about horizontal versus vertical lines. And we're asked here on the graph axes below to graph the lines given by x equals 3 and f of x equals 3. Well, the second one there, why is this not working? Here we go. The f of x equals 3, okay? We already know what that looks like, right? In fact, we're just looking at one like that. That's a horizontal line passing through 3 on the vertical axis. It would be something like this, right? So that would be the f of x equals 3. But what about x equals 3? What will the graph of that look like? Well, we could plot some points. And note that the only information we're given is x equals 3. So all we know is that the input value is 3. We don't know anything about the output value, which means that probably regardless of what the output value is, the input value is 3, right? So like, for example, we could have a point at x equals 3, output equals 0, which would be there. We could have a point at x equals 3, output equals 4, which would be up here. We could have input 3, output equals -7, which would be down here. And notice if we keep drawing dots, right, eventually we get a pattern that looks something like a line. If we connect those dots, notice we get a vertical line. Okay, then in this case would be x equals 3. So if our equation is just something like our input value equals a particular number, then we know that we're looking at a vertical line. Okay? All right. Next thing, so talking about parallel versus perpendicular lines. So you'll see in the pictures I have here, two sets of lines. And I'll tell you that in one of these sets, the lines are parallel, and they are perpendicular. Do y'all know which one's which? Okay, you're right. The ones on the left are parallel. Right, so this line here and this line, those are parallel. And we know that because the two lines, that as they extend forever and ever in each direction, they do not intersect, and they never will. And notice if we look at the slopes of those lines, right? Not like that, though. So for the first one, notice that we see a rise of 2 and a run of 1. So we see the slope is 2 over 1, which is 2. For the second one, we also see a rise of 2 and a run of 1, which gives us a slope of 2. So what do you think we conclude about the slopes of parallel lines? Right, they are the same. Okay, so then the two on the second picture on the right, these are going to be perpendicular lines. So this one here and this one here. And notice that these are lines that intersect. And not only do they intersect, but they intersect in a special way. Okay, their intersection points there form right angles. So that's what makes two lines perpendicular. And what do we notice about their slopes here? Well, one of them is negative 3/2, and the other is 2/3. You see any relationship between those? Well, if I take the slope of negative 3/2, okay, and I flip it over, so become negative 2/3, that's really close to 2/3. And what do I still have to do? Right, I have to make it positive. So as soon as I make it positive, now I have the slope of the second line there. So because of this thing of taking the reciprocal or flipping the slope over and then taking the negative of it, we say that the slopes of perpendicular lines are opposite reciprocals. Okay, and we say opposite meaning their signs are different, and then reciprocals because if we flip one or take the reciprocal of one, we should get the other. Now we need to be careful about this, right? Because that means that opposite part does not always mean that the other slope is negative. For example, in this one, the one we started with was negative, and the slope of the second line was positive. So if you start with a positive slope, or excuse me, a negative slope, to find the slope of the perpendicular line, you should end with a negative one. If you start with a negative slope, then the slope of the perpendicular line, if you start with a positive slope, the slope of the perpendicular line should be negative. Okay? All right, and so this slide here just summarizes that information. So first of all, two lines are parallel if the slopes are equal. Okay, and then it gives you some different information about perpendicular lines down below. The most important part here is this negative reciprocal part. And again, just to reiterate, if I started with a slope of, say, something like negative 3, okay, the negative reciprocal of that, and we call that slope 1, so the slope 2 then, that's what the m sub 2 means. So be the slope of my perpendicular line. Well, I first of all have to turn that negative 3 into a fraction, so that becomes negative 3 over 1. And the negative reciprocal tells me to flip it, so it becomes 1/3. And then it was negative, so now it becomes positive. So the slope, if we have a line whose slope is negative 3, the slope of a perpendicular line would be positive 1/3. Okay? All right, that's all for now. Thank you for watching.